This is Module 17, Building a Small Network of the Cisco Networks Academy, Introduction to Networks, version 7.0. First, we need to talk about the devices that would be in a small network. Now, you must remember that a small network, we use the same principles that we would use building a larger network. The majority of businesses are small. Most of the business networks are also small. A small network design is usually simple. This does not mean that it is limited to always being a simple design. When we design, we must make sure that it is expandable in case the company grows. Also, the design should also be able to contract if the company runs into hard times and has to scale back. Small networks typically have a single WAN connection provided by DSL, cable, or an Ethernet connection. Many companies will have a single WAN. But depending upon what the company does and what they determine as crucial to their business needs, they may have more than one WAN connection. Large networks require an IT department to maintain, secure, and troubleshoot network devices and to protect organizational data. Small networks are managed by a local IT technician or by a contracted professional. There are many companies that provide network services to business and manage those networks remotely. Just because it is a small company does not necessarily remove the process of making a secure network. Any small company that takes any type of credit card or payment must also be totally secure. Like large networks, small networks require planning and design to meet user requirements. Planning ensures that all requirements, cost factors, and deployment options are given due consideration. One of the first design considerations is the type of intermediary devices to use to support the network. The factors that must be considered when selecting network devices include cost, speed, and types of ports interfaces, expandability, operating system features, and services. This takes place after the planning. In the planning phase, the network administrators, along with the primaries of the company's management, must decide what services are crucial to the company doing business, what services must remain up, what things they cannot do without, and what things are absolutely necessary for their business. Also, in the initial planning, it should be included where the company intends to go, whether it be next year, 5 years, 10 years, because the network must be able to adapt and grow with the company's needs. Once the information about the absolute minimum needs of the company are determined, then the design phase can start. One of the things is what equipment the company may already have. Where could that equipment fit into the design part? It doesn't make a lot of financial sense to replace all equipment when some equipment may be very usable. It would be better to use that during the initial phase and replace it further on in time. Cost is always a major factor. You may not be able to put in the maximum that you want during the first year. The network may have to grow with the company so that it's not a huge major expense all in one year. It can be distributed over a number of years as the company grows. Speed and types of ports or interfaces is crucial. especially if your company is going to do any type of voice or video. Expandability, as was mentioned earlier. Is the company planning on expansion? And if they are planning on expansion, are they going to offer additional services? What type of operating system features and services will they be providing? When implementing a network, create an IP addressing scheme and use it. All hosts and devices within an internetwork must have a unique address. Devices that will factor into the IP addressing scheme include the end devices, the number and type of connections, whether it be wired, wireless, remote access. Do you have servers and peripheral devices, printers, security cameras, intermediary devices, including switches and access points? It is recommended that you plan, document, and maintain an IP addressing scheme based on device type. The use of a planned IP addressing scheme makes it easier to identify a type of device and to troubleshoot problems. In the initial design, you may figure a certain number of devices. It is good practice to at least double that number because the most expensive part of installing a network is not the equipment. It is the labor pulling cable and providing the connections. You may have connections that are not used at the present time, but next year, the year after, or further on down the line, those connections may be used. It is much easier to pull the cable when the initial setup is being done than to do it again at a later date. Do you want redundancy? If certain services are determined to be mission critical, then redundancy may be necessary. So, in order to maintain a high degree of reliability, redundancy is required in the network design. Redundancy helps to eliminate a single point of failure. Redundancy can be accomplished by installing duplicate equipment. It can also be accomplished by supplying duplicate network links for critical areas. One such example for a company I work for, we determined that credit card authorization was critical to what we did. During the initial build of the network, there was only one internet service provider. We realized that this would not be enough. We could have taken out two connections with the same service provider, but if the service provider went down, having two connections that are down would not help us. 2 years later, the phone company started to offer DSL services. So we had one connection via DSL, one connection via cable. We also split the network using HSRP so that some services used the DSL and some used the cable. And if one or the other went down, all services would switch over to the one that was working. This provided the redundancy that we needed to keep the credit card billing up 24/7. The goal for a good network design is to enhance the productivity of the employees and minimize network downtime. The routers and switches in a small network should be configured to support real-time traffic, such as voice and video, in an appropriate manner relative to other data traffic. A good network design will implement quality of service. Priority queuing has 4 queues. The high priority queue is always emptied first. Quality of service is a very special area and must have particular attention paid to it. At the present time, your network may not need voice or video, but in the future, it may. So implementing a quality of service configuration can be extremely important. Besides priority queuing, there are many other types of queuing techniques that will be discussed in later courses. With the design phase, you would then know what common applications that you are going to use. Are you keeping data on site, or is the data being kept off site? Are you allowing remote access into something such as a web server for your business? All these should have been considered in the initial design phase. After you have set it up, your network still needs certain types of applications and protocols in order to work. The network is only as useful as the applications that are on it. There are two forms of software programs or processes that provide access to the network. The first is network applications, applications that implement application layer protocols and are able to communicate directly with the lower layers of the protocol stack. And application layer services for applications that are not network aware, the programs that interface with the network and prepare the data for transfer. Network protocols support the applications and services used by employees in a small network. Some of these may be network administrators commonly require access to network devices and servers. The two most common remote access solutions are Telnet and Secure Shell. As mentioned previously, Secure Shell is the more accepted method because it is encrypted. Hypertext Transfer Protocol, or HTTP, also HTTPS for secure, are used between web clients and web servers. SMTP, or Simple Mail Transfer Protocol, used to send email, post office protocol, or POP3, or Internet Mail Access Protocol, IMAP, are used by clients to retrieve email. You will find that many companies, because of the amount of email that is used, many companies subcontract the email server to a third party. File Transfer Protocol and Security File Transfer Protocol, FTP or SFTP, are used to download and upload files between a client and an FTP server. DHCP, or Dynamic Host Configuration Protocol, is used by clients to acquire an IP configuration from a DHCP server. For small companies, the router can also be used as a DHCP server. Domain Name Service, or DNS, is used to resolve domain names to IP addresses. There are many free DNS services available instead of a small company creating their own DNS server. A server could provide multiple network services. For instance, a server could be an email, FTP, and SSH server. Virtualization is a good practice for this type of configuration, so that if one server becomes corrupted or attacked, it can very easily be removed and replaced with a backup. And when I say backup, I am talking about a virtual backup, not a physical backup. These network protocols comprise the fundamental toolset of a network professional, defining the processes on either end of a communication sessions, the types of messages, the syntax of the messages, meaning of the informational fields, how messages are sent and the expected response, and their interaction with the next lower layer. Many companies have established a policy of using secure versions such as SSH, SFTP, and HTTPS of these protocols whenever possible. This is very common practice in today's cyber world. For voice and video applications, businesses today are increasingly using IP telephony and streaming media to communicate with customers and business partners, as well as enabling their employees to work remotely. The network administrator must ensure the proper equipment is installed in the network and that the network devices are configured to ensure priority delivery. This is where quality of service comes in, as well as the choice of equipment. Most equipment today is referred to as integrated services, meaning that they will do voice and video as well as data. Depending upon the amount of voice or video that a company or business may use, the routers and switches need to be configured for that amount of traffic. Routers, in order to transfer voice and video, use a digital signal processor. On the Cisco site, there is a free tool to figure out what you need for a digital signal processor for the amount of phone traffic that you may have. The factors that a small network administrator must consider when supporting real-time applications. The infrastructure. Does it have the capacity and capability to support real-time applications? This should be considered during the initial design phase. Voice over IP. Voice over IP is typically less expensive than IP telephony, but at the cost of quality and features. Most voice over IP systems today are of extremely high quality. Some companies may decide to reduce the amount of bandwidth given to each call, which also would reduce the quality of the call. The amount of bandwidth is minimal for voice over IP. The best voice over IP call only uses 64K of bandwidth. That gives the user the ability to recognize who they are talking to and the mood that that person is in. IP telephony. This employs dedicated servers from call control and signaling. There are multiple types of call control and signaling servers, both proprietary, such as Cisco Communications Manager, and other free software. Communications Manager is not free, and it will support very large networks as well. Cisco also has products that just do telephony and would go right into the system as a standalone unit. You may have real-time applications. Real-time applications must support quality of service mechanisms to minimize latency issues. They may employ real-time transport protocol, or RTP, and real-time transport control protocol, RTCP, and two protocols that support real-time applications, such as if you are supporting an online gaming site, real-time applications are absolutely critical and quality of service must be factored in. To scale to a larger network, we have to consider the growth. Growth is a natural process for many small businesses, and their networks must grow accordingly. All businesses want to grow. Ideally, the network administrator has enough lead time to make intelligent decisions about growing the network in alignment with the growth of the company. And as previously discussed, the growth of the company should take place in the initial design phase. To scale a network, several elements are required. The documentation, both the physical and logical topology. In any network, documentation is key because it tells you what you have presently and gives you an indication of what you may need. An inventory of devices. This is a list of devices that use or comprise the network. In this inventory, it should not only have the make and model of the device, but which iOS and which protocols they may support. The budget. And this is an itemized IT budget. Includes the fiscal year equipment and a purchasing budget. And this should be factored in as part of a multi-year plan to improve the network. Traffic analysis. The protocols, applications, and services and their respective traffic requirements should be documented. When the network is first built, the protocols that are running may be more of data transfer. As the network grows, it may be more of voice and video. So a constant, up-to-date traffic analysis is key when expanding the network. All these elements are used to inform the decision making that accompanies the scaling of a small network. It's important to understand the type of traffic that is crossing the network as well as the current traffic flow. There are several network management tools that can be used for this purpose. So to determine traffic flow patterns, it's important to do the following. Capture traffic during peak utilization times to get a good representation of the different types of traffic. It does very little good to record traffic at midnight if the business is closed. For certain types of businesses, the time of year would also be critical. If you are working with a company that does tax preparation, then the springtime would be a much better time to look at your traffic flow patterns and protocols than it would be to look at it in the fall. Perform the capture on different network segments and devices, as some traffic will be local to a particular segment. Information gathered by the protocol analyzer is evaluated based on the source and destination of the traffic, as well as the type of traffic being sent. Some traffic may remain on site, while others may be sent to a remote server. Once that is done, the analysis can be used to make intelligent decisions on how to manage the traffic more efficiently. Data is crucial to the proper management of any network. Many operating systems provide built-in tools to display such network utilization information. These tools can be used to capture a snapshot of information, such as the following: the operating system and the operating system version, CPU utilization, RAM utilization, drive utilization, non-network applications, as well as network applications. Documenting these snapshots for employees in a small network over a period of time is very useful to identify evolving protocol requirements and associated traffic flows. You must remember that your network is a living, breathing network in that it expands and contracts with the use of the employees. It is not meant to stay stagnant. It is meant to develop over time and to adapt to new protocols, new services, and new business requirements. Once a network is built, to verify connectivity is extremely important. The most common way to verify connectivity is with the ping command. So whether your network is small and new or you are scaling an existing network, you will always want to be able to verify that your components are properly connected to each other and to the internet. The ping command available on most operating systems is the most effective way to quickly test layer 3 connectivity between a source and destination IP address. The ping command uses ICMP or Internet Control Message Protocol echo and ICMP type 8 or echo reply, which is ICMP type 0 messages. If you cannot get to your final destination, you may want to ping each interface on the path to find where your network breaks down. On Windows 10 hosts, the ping command sends 4 consecutive ICMP echo messages and expects 4 consecutive ICMP echo replies from the destination. The iOS ping sends 5 ICMP echo messages and displays an indicator for each ICMP echo reply received. Some of the indicators that we may receive are the exclamation point. The exclamation mark indicates a successful receipt of an echo reply message, and it validates a layer 3 connection between source and destination. You must remember that ICMP will only test to layer 3. The dot or a period means that time expired waiting for an echo reply message. And this indicates a connectivity problem occurred somewhere along the path. A U, an uppercase U, indicates a router along the path responded with an ICMP Type 3 destination unreachable error message. Possible reasons for this would include that the router does not know the direction to the destination network, or it cannot find the host on the destination network. Some other possible replies would include Q, M, question mark, or the and sign. However, the meaning of these are out of the scope of this particular module. You may also do an extended ping by, instead of saying ping and the IP address, just putting in the command ping. It would then ask you for which protocol do you want, IP or IPv6. You can then put in the target address. How many times do you want it to repeat? What is the size of the datagram? What is the time between datagrams? You can also go into extended commands where you can change the source address or interface. Remember, when you do a ping, it will use the address of the interface closest to the destination. This may not tell you if one of your internal networks could actually reach the destination. We could also set the DSCP value, the type of service, a DF bit. We could validate the reply. We can put in a particular data pattern. We could also do a sweep range of sizes in case you think that there is a bottleneck somewheres in the path. We can also use traceroute to verify the path and to verify that traffic is taking the path that we want it to take if that is a necessary requirement. The ping command is useful to quickly determine if there is a layer 3 connectivity problem. However, it does not identify where the problem is located along the path. Traceroute can help locate layer 3 problem areas in a network. A trace returns a list of hops as the packet is routed through a network. And the syntax of the trace command varies between operating systems. As we can see here, in a Windows host, the command is trace RT. In the iOS, it is trace route. This example is a sample output of trace route or trace RT command on a Windows 10 host. As you can see here, the first connection was made. The stars indicate that the next hop timed out. This would continue on for a period of time. In order to stop this, you can use Control C to interrupt it. In this case, the only successful response were from the gateway on R1. Trace requests to the next hop timed out as indicated by the asterisk, meaning that the next hop router did not respond or there is a failure in the network path. In this example, there appears to be a problem between R1 and R2. Here are two more examples. On the left, the trace validated it could successfully reach PCB. You'll notice that it ended after the third step. On the right, the 10.1.1.10 host was not available, and the output shows asterisk where the replies timed out. Timeouts indicate a potential network problem. On the router, you can use Control-Shift-6 to interrupt a trace route. As you may recall, on a Windows machine, it is Control-C. As a note, Windows implementation of traceroute, or traceRT, sends ICMP echo requests. The Cisco iOS and Linux use UDP with an invalid port number. The final destination will return an ICMP port unreachable message, which will still give us the equivalent of the traceRT command. Like the extended ping command, there is also an extended traceroute command, and it allows the administrator to adjust the parameters related to the command operation. The Windows traceRT command allows the input of several parameters through options in the command line. However, it is not guided like the extended traceroute in an iOS command. The following output displays the available options for a Windows traceRT command. A -D for do not resolve addresses to hostname, H for maximum hot, J for a host list, W for timeout, R for trace round trip path, S for source address to use, and 4 and 6 using IPv4 or IPv6. Multiples of these could be used in the trace RT command. The Cisco iOS extended trace route option enables the user to create a special type of trace by adjusting multiple parameters related to the command operation. As we can see in the diagram, we can give it the type of protocol, target IP address, as well as the source address. We can also give it a maximum time to live and a minimum time to live. We can also use a particular port number. This may be usable and handy if we are trying to check to see if a particular port for a server is available. Unlike Windows, the Cisco iOS will guide us through each of the options. We can use the ping and the trace route to establish a network baseline. One of the most effective tools for monitoring and troubleshooting network performance is to establish a network baseline. So one method for starting a baseline is to copy and paste the results from an executed ping, trace, or other relevant command into a text file. The text files can then be timestamped with a date and saved into an archive for later retrieval and comparison. Among items to consider are our error messages and response times from host to host. Any type of corporate network should have extensive baselines, the more extensive than we can describe in this particular course. Professional grade software tools are available for storing and maintaining baseline information. Companies who install networks, this is one of the requirements that they will fulfill after the network has been delivered. Baselines are particularly useful when an employee may say that the network is working slow. What is slow compared to what is fast? Doing a ping or a trace and comparing it with the original data could tell you if the network is actually working slow or if the employee may just be in a hurry and wants things quicker. Some of the host and iOS commands that you can have that can be used, as we have discussed already, traceroute or traceRT was one. In Windows 10, you can access the IP address details from the Network and Sharing Center to quickly view the 4 important settings: the address, the mask, the router, and the DNS. Or you can issue a command, ipconfig command, at the command line of a Windows computer. You can also use the ipconfig /all command to view the MAC address as well as multiple other details of the setup of your computer. If a host is configured as a DHCP client, the IP address configuration can be renewed using the ipconfig/release and ipconfig/renew commands. Some systems require a space between ipconfig and either release or renew. Some will take it without the space. A DNS client service on Windows PCs also optimizes the performance of a DNS name resolution by storing previously resolved names in memory. The ipconfig/display DNS command displays all of the cached DNS entries on a Windows computer system. These will time out, so what you get at one point in time may not be the same list that you would get shortly thereafter. We can verify the IP configuration on a Linux host by using the GUI on a Linux machine, and this will differ depending upon which version of Linux you may be using. In command line, it is IF config, or interface config, rather than IP config. The IF command is used to display the status of the currently active interfaces and their IP configuration, as you can see in the diagram. It also gives us the maximum transmission unit size. The Linux IP address command is used to display addresses and their properties, and it can also be used to add or delete addresses. In the GUI of a Mac host, open network preferences and go to advanced to get the IP addressing information. The IF config command can also be used to verify the interface IP configuration at the command line, the same as a Linux system. Other useful Mac OS commands to verify the host IP setting include network setup, list all network services, and network setup -get info. As a network technician, you may be using all of these operating systems. The op command is executed from Windows, Linux, or Mac command prompt. The command lists all devices currently in the op cache of the host. Op --A command displays the known IP address and MAC address bindings. The op cache only displays information from devices that have been recently accessed. There is a timer so that if the device is not accessed again, the entry will time out and be removed. To ensure that the op cache is populated, ping a device so that it will have an entry in the op table. The cache can be cleared by using the netsh interface IP delete op cache command in the event the network administrator wants to repopulate the cache with updated information. In order to perform this, you may need administrator access to the host. Some of the common show commands that we have discussed within this course: show your running config, show interfaces, show IP interface, show ARP, show IP route, show protocols, show version, show IP interface brief. These are all tools in your toolbox as a network technician. You may not use all the tools on the same job, but the tools are still there available to you. And we use these commands to diagnose what is going on within our network. You can use show CDP neighbors. CDP, or Cisco Discovery Protocol, works at layer 2 and is turned on by default. We need CDP for voice over IP phones. It is recommended that CDP, after the initial setup, be shut off, except for those phones that we need to have it on. Cisco phones use Cisco Discovery Protocol along with the switch that they're attached to identify what type of device they are so that they are put into the proper VLAN. CDP will also provide device identifiers, the configured host name of a switch, router, or other device, the address list, up to one network layer address for each protocol supported, port identifiers, the name of the local and remote port in the form of an ASCII character string, such as fast Ethernet 00. A capabilities list, whenever a specific device is a layer 2 switch or a layer 3 switch. The platform, the hardware platform. You can also say show CDP neighbors detail command and will reveal the IP address of the neighboring device as well as the operating system. Because of the amount of information CDP would provide, it is not appropriate to send to end users. This is why, in many cases, after the initial build and configuration of the network, CDP would normally be disabled except for ports that need it, such as the voice over IP. The show IP interface brief command is extremely handy. Command provides a more abbreviated output than the show IP interface command. It provides a summary of the key information for all network interfaces on a router. As we can see here in the show IP interface brief, it also tells us, besides the IP address, whether the status is up and the protocol is up. Remember, status means electrical, while protocol is the actual protocol. You could have up and down, down, up and up, down and down. You can never have down and up. It cannot be down electrically and still have the protocol functioning. Administratively down means that you did not put in the no shut command. Troubleshooting methodologies. Troubleshooting is an important part of any network. You cannot normally assume the network will work perfectly for an indefinite period of time. Troubleshooting is a logical approach and must remain in a logical order. First, you must identify the problem. In order to identify the problem, it is important that you know how the network works. If you did not know how an automobile worked, when you turn the key and nothing happened, you would assume anything. You could say it was out of gas. Obviously, that is not the case. But once you know how an automobile works and you turn the key, that would lead you to speculation that maybe you have a battery problem if nothing happens. So it is important to understand how the network works. So identifying the problem. This is the first step in the troubleshooting process. Although tools can be used in this step, a conversation with the user is often very helpful. How you approach a user is also critical. You want them to be a partner with you as far as the troubleshooting, not an adversary. So use terms to draw out the type of information that you need. Once you have gotten the information, establish a theory of the probable cause. So after the problem is identified, such as is it local to a machine, to a network, to the entire company? After the problem is identified, try to establish a theory of probable causes. Once we know the extent of the problem, we could narrow it down. Is there one common piece of equipment that interconnects all the devices having an issue? Or is it just one device? It may give you more than one probable cause. Test the theory to determine the cause. Based on the probable cause, test your theories to determine which one is the cause of the problem. It is good before changing or modifying an iOS to store the configuration. This way, if you change the iOS and it does not correct the problem, you can restore it to what it was. If a quick fix does not correct the problem, you might need to research the problem further to establish the exact cause. Remember, making any change may change something else with unintended consequences. Establish a plan of action and implement the solution. Some of the things that should be considered is the time of day that you can implement a solution. A maintenance window is always good to have. Verify the solution and implement any preventative measures. You must verify that the network is fully functional after any solution has been implemented. Once done, document all findings, actions, and outcomes, because this problem may occur again in the future, or something similar. Or it is possible that some program that is not in use no longer runs because of what was done. It is important to have that documentation so you can go back and correct any issues that you may have inadvertently caused. In any company, the hardest thing to teach a technician is when to realize they are over their head and to stop. So in some situations, it may not be possible to resolve the problem immediately. A problem should be escalated when it requires a manager's decision, some specific expertise, or network access level unavailable to the troubleshooting technician. The company's policy should clearly state when and how a technician should escalate a problem. Some technicians can do more damage to a network by not stopping than using a proper procedure of calling a manager. It is also important to realize that some equipment in the company may be leased equipment and not owned by the company itself. This then becomes the responsibility of the leasing company and not the company that is using the equipment. The debug command is also extremely handy as well as being extremely dangerous to use. The iOS debug command allows the administrator to display OS processes, protocols, mechanisms, and event messages in real time for analysis. Because debug takes a tremendous amount of processing power, you want to only use it on very specific things. You would never say debug all because the amount of power that it takes would stop you from doing anything else with the device, including shutting off debug. All debug commands are entered in privileged exec mode, and the Cisco iOS allows for narrowing the output of debug to include only the relevant features or sub-features. Use debug commands only to troubleshoot specific problems. Once you are done using debug, shut it off. To list a brief description of all the debugging command options, use the debug space question mark command in privileged exec mode. To turn off a specific debugging feature, you can add the no keyword in front of debug. Also, you can say undebug or u space all as an abbreviated form. To turn off all active debug commands at once, undebug all or u space all. Be cautious using some debug commands as they may generate a substantial amount of output and use a large portion of system resources. The router could easily get so busy displaying debug messages that it would not have enough processing power to perform its network functions or even listen to commands to turn off debugging. Debug and certain other iOS messages output is not automatically displayed on remote connections. And this is because log messages are prevented from being displayed on your VTY lines. If you wish to display these commands, you can put in the term or the command terminal monitor in privileged exec command. To stop logging messages on a terminal, use the terminal no monitor privileged exec command. And as you can see in the diagrams, one shows us the messages received, the other does not. Some troubleshooting scenarios one very common is in duplex. Interconnecting Ethernet interfaces must operate in the same duplex mode. They are either full duplex or half duplex. You never connect a full to a half, or configure one side to be full and the other side to be half. They are either both full, which is the preferred method, or half if necessary for best communication performance and to avoid inefficiency and latency on the link. The Ethernet auto negotiation feature facilitates configuration. It minimizes problems and maximizes link performance between two interconnecting Ethernet links. The connected devices first announce their supported capabilities and then choose the highest performance mode supported by both ends. Does this work 100% of the time? No, there is the possibility that they will mismatch. If one of the two connected devices are operating in full duplex and the other is operating half duplex, a duplex mismatch occurs. While data communication will occur through a link with a duplex mismatch, link performance will be very poor. You will have a number of collisions, but eventually data will get through. It is handy to show the interface to see if you are getting an inordinate amount of collisions. Duplex mismatches are typically caused by a misconfigured interface or, in a rare instance, by a failed auto negotiation. Duplex mismatches may be difficult to troubleshoot as the communication between devices still occurs. Two common Causes of incorrect IPv4 assignment are manual assignment mistake or DHCP-related issues. It is very common to type in the wrong IP address. Network administrators often have to manually assign IP addresses to devices such as servers and routers. If a mistake is made during the assignment, then communications issues with the device are very likely to occur. On an iOS device, use the Show IP Interface or Show IP Interface Brief commands to verify what IPv4 addresses are assigned to the network interfaces. For example, issuing the Show IP Interface Brief command as shown would validate the interface status on R1. This information could then be compared with the default gateway on a host device. On end devices, on a Windows-based machine, when the device cannot contact the DHCP server, Windows will automatically assign an address belonging to the 169.254, the link local feature in IPv4. And this feature, although not being called link local, in Windows it's referred to as automatic private IP addressing, or APIPA. A computer with the APIPA address will not be able to communicate with other devices in the network because those devices will most likely not belong to that network. Of the systems, such as Linux and Mac, do not use APIPA. If the device is unable to communicate with the DHCP server, then the server cannot assign an IPv4 address for the specific network, and the device will not be able to communicate. If we want to verify the IP address, as mentioned earlier, in a Windows-based machine, use the ipconfig command. It is also possible that the DHCP server was misconfigured so that the addresses are not within the network. The default gateway could be wrong. The DNS could be wrong. It is also good to take a look at the lease times so that starvation of DHCP addresses does not occur. Going to the default gateway for an end device is the closest networking device belonging to the same network as the end device. This device that can forward traffic to other networks. If a device has an incorrect or non-existent default gateway address, it will not be able to communicate with devices in remote networks. Similar to IPv4 addressing issues, default gateway problems can be related to misconfiguration, in the case of a manual assignment, DHCP problems, if an automatic assignment is in use. To verify your default gateway, again, use the ipconfig command. On a router, use the show IP route command to list the routing table and verify that the default gateway, known as a default route or a route of last resort, has been set. This route is used when the destination address of the packet does not match any routes in its routing table. But DNS is common for users to mistakenly relate the operation of an internet link to the availability of the DNS. A DNS server address can be manually or automatically assigned via DHCP, such as 8.8.8.8, which is a Google DNS server. Although it is common for companies and organizations to manage their own DNS servers, any reachable DNS server can be used to resolve names. Cisco offers OpenDNS, which provides secure DNS service by filtering phishing and some malware sites. OpenDNS addresses are 208.67.222.222 and 208.67.220.220. Advanced features such as web content filtering and security are available on this to families and businesses. We can use the ipconfig/all command as shown to verify which DNS server is used by the Windows computer. We can also use the nslookup command as another useful DNS troubleshooting tool for PCs. With nslookup, a user can manually place DNS queries and analyze the DNS results. This concludes Chapter 17, the last chapter in the Introduction to Network Cisco Academy course.